Perhaps you are one of these people who has formed the view, maybe because your gut is telling you, and it's always right, that a hydrogen fuel cell vehicle is little more than a bomb on wheels, or that a battery electric vehicle is little more than a towering inferno minus the tower. If you are and you want to hang on to that view, I strongly advise you to click away now. I'm John Cadogan from AutoExpert.com.au, and I get new cars cheap. Not too many hydrogen cars cheap at the moment, I note, but all the other cars, yeah, pretty much. Australia only, website, card. Now, scientific literacy. It's just like lemmings off the cliff, isn't it? You don't have to know anything about science to have a view about sciencey stuff. You just need to have your confirmation bias weaponised using social media, where you can join a club of a whole bunch of people whose other guts are telling them what your gut is telling you, and therefore, safety in numbers, you must be right. James Schultz seems quite confident in his position on this one, so he's typical of respondents I get about hydrogen and the dangers therein. So James says, when I went scuba recreationally, the tanks were pressurised at about 3,000 psi, which is 200 bar. 200 of that's 1 bar, so 200 of them, 200 atmospheres. That's flat out amazing, and they're only aluminum in America. Something the instructors hammered on was making sure the tanks were secure in transport. Yeah, even when they're empty, dude. Good idea, because wouldn't want one of them slamming me in the back of a dome in a crash. That could end badly, couldn't it? An annual visual inspection and a 5-year hydrostatic test is required for certification. Makes sense. When filling the tanks, they were connected to the compressor and placed into a watered tank in case of failure. Yeah, water's not a bad containment mechanism. And that was for a relatively benign gas, air. Okay? But anytime you start to add gases like methane or hydrogen, the risk jumps exponentially, does it? It doesn't increase linearly, it's exponential, is it? You now have the potential for a fuel-air bomb to be driven around by some mentally deficient yahoo who thinks that his car is fine, doesn't need to have the tank tested. It's not a bomb, dude. We'll get to that. Even though he's driving around with ball tyres, spongy brakes, 1 headlight and a cracked windshield. It's actually the same as everyone else who's driving around with a friggin' Molotov cocktail. Oh, sorry, a fuel friggin' tank. And that's not even counting the responsible people that would have the required tests done on schedule that happen to get rear-ended at 45 miles an hour while at a stoplight by the above-mentioned mentally deficient yahoo. The point is, if they want to switch from diesel to hydrogen for on-the-road long-trawl trucking, not a problem. They weigh metric F-tons anyway. Just apply some of that weight as armour. Kind of hard to do that in a passenger car. Right. Okay, so at the risk of letting some facts intrude into what appears to be a bit of a rant about the supposed dangers of hydrogen, the whole fuel-air bomb thing, which I don't believe is real, we need to talk about a few things, right? 1, hydrogen is new in cars, but it's not new in society because hydrogen gas is used in industry in many different processes, and there's not much of it in the air that we breathe, so it has to be manufactured. Before you say that hydrogen is the most common element in the universe, which is true, there is a difference between elemental hydrogen, which is scattered around the universe in great quantities, and gaseous hydrogen, which hardly exists here on Earth unless you make it. The air you're breathing now is 78% nitrogen and 21% oxygen and 1% everything else. That's every other gas in total. 1%, more or less. Okay? So if you want hydrogen on Earth to manufacture the flat glass for a TV screen or something, then you need to manufacture the hydrogen. And we manufacture rather a lot of it. In fact, according to ARENA, which is the International Renewable Energy Agency, Okay, annual production of hydrogen is 120 million tonnes. And there's a whole bunch of logistics around that. Not only do you have to make it, but you've got to make it and you've got to move it to where it gets used. And we do that in pipelines, and we chill it out to almost absolute zero where it liquefies, and we put it in these cryonic storage vessels and ship it around the world, and we put it in high pressure containers on goods trains and in trucks, and lately we use it in a small number of fuel cell electric vehicles also. But when was the last time, looking at the empirical evidence for the danger of hydrogen, we're making 120 million tonnes a year, like when was the last time you heard of a hydrogen incident, like a hydrogen explosion? I haven't heard of one at all, and I went looking and I found 6 this decade. This decade, 2020, 2021, 2022. We've had 3 years, meaning 360 million tonnes of hydrogen gas. There's been 6 incidents involving 1 death and 5 non-life-threatening injuries. And I'd suggest that's a pretty good result around the world for a potentially dangerous substance like hydrogen. And it's always dangerous to be in close proximity to a lot of stored energy. This is the same as driving next to a tanker full of 20,000 litres of petrol. That's a fire looking for a place to happen, and the reason it doesn't happen is because we've got practices and procedures and safe working standards and things of this nature that sideline most of the risks. Like, when was the last time you heard of a petrol tanker exploding just on the road near you? It statistically doesn't happen, dude, because we've got a whole bunch of brainiacs figuring out safe ways to deal with dangerous shit. That's essentially how this works. Now, I'd suggest that the most likely way for somebody to blow themselves up with hydrogen is to make it yourself. So don't do that. And the way it always happens, when you hear on the news that some idiot blew himself up with hydrogen, he's electrolyzing water. And when you do that, you get hydrogen gas comes off one electrode and oxygen gas comes off the other electrode. If you're so stupid that you collect them in the same container, then you've got a perfectly good stoichiometric mixture of hydrogen gas and oxygen gas in the same container, ready to rip, looking for a spark. That's bad. It can just be static electricity, and all of a sudden you're dead, the roof's off your shed, the street is cordoned off, and there's a full-on hazmat incident. So best not play with things that you don't understand, I'd suggest. As for actual safe use of hydrogen in industry and on the road, that's already pretty well sorted out. And just want to address the difference between a bomb and a fire. Like, a bomb is a really complex thing, and I'm not going to do a tutorial on how to make a bomb. That's ridiculous. But a bomb is basically a container full of a whole bunch of chemicals designed to react all at the same time and deliver a sort of supersonic shockwave. I don't think I'm letting any cats out of any bags saying that. What we're talking about is a fuel, or a fuel-like substance. And the thing fuels do is they burn. Okay, so what you need for a fire is you need a fuel and an oxidizer, like the oxygen in air, and then you need something to kick it off, like a suitably high temperature or a source of ignition like a spark. And if you've got all of those things, then you get a fire. And obviously, hydrogen is the same as any other fuel when it comes to those things. If you get the magic set of ingredients together, then you get a fire. But you don't get an explosion so much. This is the same as petrol or LPG, but there are plenty of reasons why hydrogen, for example, is safer than petrol or LPG. If you rupture a petrol tank in a car crash, liquid petrol leaks out all over the floor, and it's just evaporating this sort of highly flammable vapour, and all it's looking for is a spark. And any source of spark will do. Bit of static electricity, someone smoking nearby, whatever. Liquid petrol on the ground is really dangerous. And LPG, like if you have an LPG leak, LPG is heavier than air. So if the wind's not blowing, or if you have an LPG leak in your basement, then the basement can fill up with LPG. It will not dissipate. It will sink and look for a low spot. It could even be the sewer or a storm water drain or something of that nature where LPG will pool and wait for a source of ignition. Whereas hydrogen gas is much lighter than air and it dissipates extremely rapidly, and the risk of a fire is greatly reduced in any sort of basically ventilated area into which hydrogen escapes. If you've got a gas tank, and it can be an LPG tank or it can be a hydrogen tank, it doesn't really matter. If it's in a fire, all that happens is it heats up and the pressure relief valve opens, and that means the gas that vents catches fire. The tank does not explode. There are so many videos on YouTube of hydrogen tanks being tested in fires and LPG tanks being scientifically tested in fires, and all that ever happens is the pressure relief valve opens and a vent of fire escapes. This is, in a sense, a lot safer than what happens if you rupture the fuel tank and the floor around the car catches fire, particularly if you're trapped in it. Okay, so there's that. On the negative side about hydrogen, it has actually got a fairly wide range of mixtures with air in which it's flammable. I think it's flammable between 4 and 74% in air, and has even greater flammability in contact with pure oxygen. So it's also got a fairly low amount of activation energy. You don't need much of a spark to set it off, although it does have a higher auto ignition temperature than petrol. So there's that. There's also the risk of being stored at 700 bar, like that's 700 atmospheres, and there's a lot of mechanical energy in the gas. So if the tank were to rupture catastrophically, that would release a lot of energy rapidly, but I can't remember the last time I heard of that ever happening. So the tanks are pretty well designed. Incidentally, the hydrogen tanks are not even steel, because steel is subject to a problem called hydrogen embrittlement, where proximity to hydrogen gas gets into the steel and makes it brittle. So in practice, what you do is you make a hydrogen tank by getting a plastic tank and wrapping it in a shit ton of carbon fibre, which results in a fairly crash-proof kind of structure. So although you can't build a suit of armour in a passenger car, the tank itself is mechanically very robust, and they do crash test hydrogen fuel cell vehicles. The tanks don't fail. They also burn hydrogen fuel cell vehicles, and the tanks don't fail. They function as they were intended to do. So the other thing you've got to bear in mind about hydrogen fire is it's pretty hard to see, and you do need to make sure that the space is ventilated, not unlike petrol, LPG, every other fuel. So I'd suggest that we are in the domain of the devil you know versus the devil you don't know. Most people don't shit themselves when there's 20,000 litres of petrol next to them, whereas petrol is an exceedingly dangerous substance. It's toxic apart from anything else in the way that hydrogen gas is not. So there's that. Moving on now to the whole battery thing. Okay, this is from Russ Tyler. I got this the other day too by email, and Russ says, I just heard of half of a talk on the radio about problems with lithium-ion batteries. From the bit I heard, it sounded like under certain conditions they can heat up and burn and then give off very toxic smoke. I heard something similar some time ago, but didn't again get the full story. I'd be interested in your thoughts on these batteries. Cheers, Russ. I also got this just earlier today from Kiro NZ, who says all EVs should get a 0-star rating for carrying around a giant lithium fire waiting to happen. So I guess they're flip sides of the same coin, and I'm not having a shot at Russ for being concerned about the potential fires of lithium ion, right? The problem with lithium ion batteries is that they are amenable, susceptible to this thing called thermal runaway, which is a catastrophic failure mechanism for many lithium-ion batteries. Just as big a problem for the battery in this camera recording this package, and those power tool batteries up on the wall there, and the battery in your electric car. Essentially what happens is you get this imbalance of heat, like the battery generates some heat, and if the heat doesn't escape, the temperature of the battery increases, this happens all the time, right? It happens to you if you go and work outside on a hot summer's day. You generate heat by working hard, digging a hole, whatever. The sun's like, and your cooling system goes into overdrive. You sweat like a pig. But if it's really hot, really humid, you're working really hard, you can't lose heat at the same rate that you are generating it internally, and ultimately you will overheat. Same thing with a battery. Okay? And a lot of things can cause these overheating conditions in batteries, like mechanical damage. You can drop your smartphone into an airline seat in the fully reclined position while you fly across the Pacific Ocean, and then when the seatbelt sign comes on and you've got to return your seat to the upright position for landing, you press, seat comes up and it folds your phone in half, and the mechanical damage just causes a short circuit internally in the battery, which starts to overheat because of the rate of discharge. And the same thing can happen in a crash in a car. So you can also have failures of cooling systems or the battery management system. The mechanical damage thing is real. You can overcharge it as well. And if any of these things happen, you open the door to thermal runaway. So what happens is, in a battery, the electrolyte in the battery gets hotter and hotter and hotter, and at some point in the temperature spectrum, the electrolyte in the battery starts to decompose. And when that happens, the reaction is exothermic, so it generates even more heat. And the problem with the electrolytes is that they're full of oxygen, like elemental oxygen. They're full of phosphates and things of that nature. So they've got PO4s in them, which is a lot of oxygen, and when it decomposes, it liberates oxygen gas. So you've got something getting hotter and hotter and hotter and generating its own oxygen gas, which means that when it burns, you can't put it out because it's generating its own heat and it's generating its own oxygen, and it's a source of its own fuel. And the way you fight a fire, typically, you get a bushfire, you dump water on it, water cools it down and deprives the fuel from contact with atmospheric oxygen, fire goes out. That won't work with a lithium-ion battery, okay? So that's something of a problem. And when that kicks off, it kicks off really rapidly. And here's the problem that I see with lithium-ion batteries in cars in close proximity. We haven't changed the building regulations, and we've got charging bays outside where electric cars park next to other electric cars. So if there is a problem with one electric car, that can easily jump to other electric cars. And with fledgling technology, where you haven't got very many electric cars, it's unlikely for that to be all that newsworthy. But when we get to electric utopia, where every car is electric and you've got these multi-storey apartment blocks in the city and they've got multi-storey basement car parks with electric cars parked next to other electric cars, all with their own chargers, all you need is one electric car to have a defect like that and have a thermal runaway. And that will quickly spread to the other nearby electric cars. And before you know it, you've got a whole floor in the basement on fire, really hot, can't be fought. The sprinkler system, which was not designed with that in mind, cannot cope with that stuff, and it's just going to start to burn. And these fires are particularly energetic and particularly hot. And in a concrete, quote-unquote, skyscraper, like a concrete building with columns and floors, like columns going up into the sky and floors hanging off the columns, there's two things you need. All the compression in the concrete, at the risk of being a civil engineer momentarily, which is something I'm not qualified for, but pretty basic. Most people should understand this. The concrete is there to carry compressive stresses, okay? And they put steel in the concrete to carry the tensile stresses. The tensile loads are all carried by the steel reinforcement in the concrete. And if you get the concrete hot enough, because the fire is energetic enough, the steel starts to fail and the concrete can't carry the tension and the building starts to collapse. So I'd suggest that one of the conversations that we're really not having in relation to electric cars and their widespread adoption in our built-up areas in buildings is we're not talking about how we need to change the building codes and the firefighting codes to deal with the problem of an isolated thermal runaway turning into 40 or 50 EVs all parked on the same level and all developing their own little thermal runaway that turns into a ginormous frigging thermal runaway. And if you think I'm being, melodramatic about that because you believe in electric utopia and you're part of that tribe and you don't really like people having a shot at it, this is a real shot. It's not having a shot at you or your tribe. This is about keeping people and society safer. We're not having this chat. If you want to look at an example of that, Google the words Felicity Ace. Okay, the Felicity Ace was a cargo ship full of electric Volkswagens, basically, or it had enough electric Volkswagens in it where there was a fire and the fire spread to other electric vehicles and it could not be extinguished and it sunk the whole ship. Okay, just look at the timeline of that, see how it happened, and this is a risk when you put a few dozen EVs on the one level of an apartment block in the CBD. It's a real potential problem. And nobody is talking about what systems do we put in place and how do we change the building infrastructure and the protocols to keep people safe when this happens unexpectedly at 3 a.m. And incidentally, it doesn't even have to be the electric vehicle that fails. It doesn't have to be the battery that fails. It could just be a fire that starts for some other reason and spreads to an electric car, because all that has to happen is the battery has to get too hot. And when that happens, the thermal runaway starts. So it could be as simple as your electric car is parked in your garage and there is a problem in the garage. Some rat eats through some item of electronics that you've got running in your garage, and all of a sudden a power tool battery has a thermal runaway, the structure starts burning, and then all of a sudden there's a massive thermal runaway in the vehicle. Okay, we're not talking about that, and perhaps we should, but I'd also suggest, just for complete balance, that every internal combustion car, like if you had to have a design brief for a device that was really likely to catch fire, you'd just take every car on the road and you'd say, well, let's put 50 litres of one of the most combustible substances imaginable in a steel or a plastic tank up the back, and let's pump it through a mass-produced, glorified drinking straw to the engine up the other end, that's 3 or 4 metres away, and let's hold the whole system together with 20-cent clips from China, and then let's put the whole device in an airstream at 100 kilometres an hour on a 30-degree day, 30 degrees C, and let's just wait and see what happens, because you've got everything that you need for a catastrophic thermal event in every internal combustion car on the road. And I'd suggest that that's already happening, because I looked at Fire and Rescue New South Wales, which does a fantastic job. According to them, the most recent data I could get is that they attend roughly 3,000 vehicle fires every year in New South Wales, okay, which is the state in which I live. So there's about 6 million registered vehicles in New South Wales, 3,000 fires every year. And that means already out there on the roads around us today, roughly 1 vehicle in every 2,000 is going to catch fire this year. All right, that's already happening. And no one, especially the people arcing up about hydrogen and batteries, none of those people is arcing up about the 1 in 2,000 vehicles that is already catastrophically burning to the ground around us in ambient society.